Hi students, all of you welcome. Welcome to Sunil Engineering Academy. I am Sunil Kumar Bandaru. Students, in this general science physics, we have already completed the topics electricity, magnets and magnetism, work, power, energy. So you can watch those in the playlist. And these sessions are useful for all your competitive examinations, including RRB and SSC. After these theory sessions, we will also practice topic-wise MCQs. Okay, so you have to do only thing, you have to attend each and every session, and also please share the sessions to all your friends. Whenever you are clicking on like and also sharing, then only I will get the interest to take the more sessions. Okay, so our next sessions will be in your hand only. Please try to share and click on like button, and also please give the comment. Okay, let us start the session, guys. So in the previous session we have completed, just wait guys. In the previous session we have completed work, power, energy. Now we are going to start motion. Okay, very important topic, motion. Before going to discuss the motion, we have to understand the rest. Okay, so what is the rest? What is the motion? You know very well, rest is nothing but if any body is continuously occupy the same place. Okay, if it is not at all moving means you can say that is in the rest position only. If any body is moving, we can say that is in motion. Okay, that is in motion. So we can define this one. Rest is nothing but a body is said to be in rest. A body is said to be in rest if it continuously occupy the same place. Okay, rest if it continuously to occupy same position for any length of time. Is said to be rest. Okay, and in the same way, what is the motion? Motion is nothing but the same body. If it is moving, we can say that is the motion. Okay, for example, if a body is stand still, if it is a very big rock, okay, let us take a 1000 kgs of rock. If you are not at all giving any force, it is always in the rest position. Okay, so it is in the rest position. Motion means, motion is nothing but change of position. If change of position with respect to time. Okay, so whenever the position changes, for example, if a body is here, after 1 minute it is here, after 2 minutes it is in here, that means it is in the motion. Okay, now in this motion we have to discuss the two important terms, that is distance and displacement. Distance and displacement, very important topics. What is this distance? No need of definition and all those. Okay, in a simple manner, distance is nothing but total length covered by any body is nothing but distance, irrespective of direction. In the distance, we are not at all considering the direction. Whatever the total path is there, that is covered by any body, is nothing but distance. Okay, so it is the length of total path, the total path covered by body. Body means any object, guys. Okay. So in the physics we are using any object is generally called as body. Okay. So length of the total path covered by any body is nothing but distance. This by body without direction. Okay. Without considering direction. Here in the same way displacement. Displacement is nothing but shortest distance or shortest path covered by body. Shortest path covered by body. Okay, shortest path covered by body. So that means you can say shortest distance. Simply you can say shortest distance. Shortest distance. Okay, clear? So the difference between distance and displacement. Let us take some example. Then we will clear in a very good manner. Okay. So in some example, distance, displacement. For example, if any body is moving in a straight line motion, moving in a straight line motion. If the body is at A place, after some time it moves to B place, that is nothing but let us take a 10 kilometer. From B to moving it is to C, it is a 5 kilometer. Okay, so now it is in the straight line motion. Body is in straight line motion. In this case, what is happening? So what is the total distance? What is the total distance here? Distance is the total path covered by body, or total path covered by vehicle, or total path covered by car. Let us take it is a car. Okay, it is moving from A to B and B to C. Total distance is nothing but A to B plus B to C. Total 15 kilometer. In the same way, what is the displacement here? It is the shortest distance now. So from A to C, if you go with any other like this or any other manner, that may be a longer distance. Straight line only the shorter. Always straight line only the shorter. Correct? So that means here distance and displacement both will be same. Displacement also 15 kilometer only. So you can note down one point. Very important point. In straight line motion, in straight line one way direction, one directional motion. Okay, only one directional. And in case of reversal direction, that may be changes. Okay, straight line one way directional motion. Displacement is equal to distance. Very important point. Displacement is equal to distance. Okay, so in straight line one way directional motion, displacement is equal to distance. In case of bidirectional, for example, if you can say bidirectional case, if a car is moving from A to B, okay, 10 kilometers, after that it is again moving from B to let us take B to A, for example, B to A, or let us take some another point. If it is considered as a C, the distance between A and C is 5 kilometer. Okay, first of all, body starts from A, okay, and then from B to again it is moving to C. Okay, so in the same direction. Here you may confuse it in this way. So again it is moving in the same direction like this. Okay. So if any body starts from A and then moving to B and then B to C, it is moving. Okay. So here car or any body is moving A to B and then B to C. In this case, what is the distance? What is the distance? Distance is nothing but total path covered by body. That means in the vehicle we have 1 meter reading is there now. Total distance meter, odometer reading. That reading is nothing but distance. Okay. First of all, it is moving A to B. It takes 10 kilometer. B to A 10 kilometers. Total 20. From A to C 5. Total 25. 10 plus 10 plus 5. 25. All of you clear? So the distance is nothing but like a vehicle reading. Now you will get a clear idea. Okay, irrespective of direction, it is a vehicle reading. Now coming to what is the displacement in the same case? Displacement, shortest distance. Shortest distance from initial to final. Initial to final. So what is the initial? Initial A, final C. So A to C. Displacement is nothing but A to C only. A to C means 5 kilometers. Okay, that is the shortest only, na? A to C is the shortest. So displacement is the shortest. Shortest. Okay. Or if you want to take in the directional manner, A to B, it is if you can consider that is forward direction is a positive. Let us take it is a plus. Reversal direction, you are taking minus 15 kilometer. Correct? Minus 10, minus 5. Total minus 15. So that means minus 5. That means if you can consider forward is a positive, it is a reversal direction in the from A to C. Okay. So that means here plus and minus are very important. Here all are plus 10 plus 10 plus 5. Here plus 10 minus 15. So that means it depends upon the direction. But distance may not depends upon the direction. So from these two cases, we can say in the case, first case, we got displacement is equal to distance. Correct. Let us take this is the case 1. Let us take this is the case 2 for easy understanding. In the case 2, what you got? Displacement is less than distance. From these two, we can conclude that displacement always less than or equal to distance. Correct? Displacement is always less than or equal to distance. And if distance is equal to 0, that is the low. So displacement is the shortest now. So displacement also 0. Displacement also 0. If displacement is equal to 0, distance may or may not be 0. May or may not be 0. Okay. Why? Because let us take this one. Why? Example. If a car is moving from A to B, again it is moving from B to A. Okay, again it is moving B to A. Then what is the distance, guys? In this case, what is the distance? Total path covered by body. Let us take 10 kilometer. 10 plus 10, that is 20 kilometer. Okay, 20 kilometer. In this case, what is the displacement? Shortest distance from initial to final. Here initial to final. Initial to final. So initial is A, final also A only. A to A distance is 0. Correct? So here displacement is 0, but distance may or may not be 0. Clear? These 2 points. Very important statement. Note down. And this statement also very important for exams. Displacement less than or equal to distance. And one more thing we got here in the distance and displacement. Here only magnitude, not direction. Depends only on magnitude. Only magnitude, no direction. Okay, here depends. Take a depends on both magnitude and direction. So that means distance is the only magnitude means scalar quantity. So note down one very important point, which is a scalar quantity. Scalar quantity is nothing but which depends only on magnitude but not direction. Displacement is a vector quantity. Why? Because vector quantity means vector quantity is nothing but which depends both magnitude and direction. Which depends both magnitude and direction. Those are vector quantities. So distance is a scalar, displacement is a vector. Okay, all of you clear? Very important. Distance between displacement. Okay, for example, let us take one more example. In triangular motion, what is happening? In triangular motion, if a object is at A, moving A to B. Okay, A to B. Let us take it is a 10 kilometer. And from B to it is moving to C. It is also a 10 kilometer. Okay, in this case, what is the distance? The distance is total path covered by body. Total path covered by body. So A to B plus B to C. So total 10 plus 10, 20 kilometer. And what about the displacement, guys? Shortest path from initial to final path covered by body from initial to final. What is the shortest, guys? A to C is the shortest now. Shortest is AC. So if you want AC, root of 10 square plus 10 square. Okay, root 200. Root 200 means less than 20. So from this one also you can get idea. Displacement is less than distance we got. Is less than distance we got. Okay. Next one, in case of circular, let us take a circular motion. This is a very interesting motion. Okay. For example, let us take a circle. Let us take a circle. It is very difficult to draw a circle by using the pen tab. Okay. So please don't laugh. Huh? Okay. Yes. Let us take it is the center. It is the radius. Okay. This is the radius. Let us take object is at A. Okay. If A completes one revolution 1 revolution. In this case, what is the distance? What is the displacement? Come on. Here distance is nothing but total path covered by body. So from starts to A, it is moving and moving, again reaches to A. That is the 1 revolution, correct? Starts from A and completes 1 revolution means you can say A. So in this case, what is the total distance, total circumference? Circumference. That is nothing but 2 pi r, correct? Circle circumference is nothing but 2 pi r. Displacement is nothing but shortest. Okay, from shortest distance from A to, again it starts from A and again reaches to A only now, A to A. So then what is the displacement? 0. So in the circular motion, displacement may be 0. Starts from A and reaches the same point. So initial and final point both are same. Initial and final point are both are same. So A is the initial and again A is the final. So initial to final is 0. In case if A completes half revolution, in this case half revolution, that means here let us take a point B. In this case, what is the distance? Half of the circumference, 2 pi r by 2, that is pi r. And then what is the displacement here? What is the displacement? Shortest path from A to B. Shortest path from A to B is straight line. Straight line. This is the r radius, means this is also r radius. So r plus r, that is equal to 2r. In this place also displacement is less. Displacement is less than distance, correct? Pi r means 3.14 into r. Just here 2 into r only. Clear? So in the circular motion, full revolution, distance is 2 pi r, displacement is 0. Half revolution, pi r and 2r. These two are very important. Okay, these are the previous bits in most of the railway examinations. Okay, I think all of you got it. In all the ways, in all the examples, distance and displacement, very, very important, guys. And students, if you like my class, please click on like option. You may forget at the end, so try to click now only. Okay. And most of the students are not sharing, guys. Please try to share. Whenever more number of students watching the class, then educator feel happy. Okay, so here I may not get lakhs of money and like that. Okay, so just it makes me very happy. Okay, so now coming to the next one, speed vs velocity. Speed and velocity. There is a small difference in the speed and velocity. Okay, both are generally denotes with v only. Speed also v, velocity also v. Here only thing is nothing but speed depends upon distance. Speed is equal to distance by time. Units are meter per second. Velocity depends upon displacement by time. That is only the difference. Displacement by time. So in the straight line motion, distance displacement same. Then speed and velocity also same. Whenever the direction changes, then only there is a problem, there is a difference is there. That means distance not depend upon direction, so speed also not depend upon direction. So speed is a scalar quantity, very important. Speed is scalar quantity because not depends upon direction. Displacement depend upon direction, so velocity also depends upon direction. So velocity is a vector, very important. Okay, both units are meter per second only. Okay. Now in the velocity, we have some one important small topic is there, that is generally called it as uniform velocity. What is that uniform velocity? Uniform velocity. Uniform velocity means if any body covers equal distance in equal interval of time in any one direction, in the same direction. Okay, so note down, same direction, in same direction. Okay, in same direction, covers equal distance in equal interval of time, equal distances in equal interval of time, then you can see that is the uniform velocity. The same way non-uniform velocity, if any of this is not follows, that is a non-uniform velocity. Simple. Non-uniform velocity. Okay. If anything is said to be a non-uniform velocity, that means the velocity is said to be non-uniform. The first case, if its speed changes means generally maybe distance or changes or time changes. If its direction changes, third one, both changes. Okay, both magnitude, that means speed and direction. Okay, or if you want to take the speed place, you can take velocity, speed or velocity change. Velocity changes, that is distance or displacement changes. Okay, then you can say that is the non-uniform velocity. After this one more important topic, speed velocity. So we can also say that here a small curve also there. If you draw the curve between speed and velocities. So speed is nothing but distance by time, velocity displacement by time. So displacement generally denoted with the letter S. Okay, so if you draw the curve between these two, as time changes, distance changes. That means it is uniform, that is linear, slope. So here you will get the question like the slope of distance time graph gives. The slope of distance time graph gives speed. Okay, slope of distance and time graph gives speed. Here the slope of displacement and time, that is only the question. Displacement time. So the change in displacement by time is velocity. So here slope. The slope of displacement vs time gives velocity. Okay, note down. Slope of distance vs time gives speed. Here slope of displacement vs time gives velocity. Okay, now after this we have to take acceleration. Another important thing is acceleration. Acceleration is denoted with letter A. Acceleration is nothing but change in velocity. Change in velocity, that means rate of change in velocity. rate of change in velocity. Okay, as the time changes, if the velocity changes, then you can say it has acceleration. You know very well it is a not a new term. Okay, generally we are using that one while bike riding. So the bike riding accelerator is there now. Accelerator. Whenever the accelerator changes means the velocity. That means speed changes or not. Okay, so here. So rate of change in velocity. Rate of change in velocity or rate of change of velocity is nothing but acceleration. Okay, nothing but acceleration. So let us take u is initial velocity, v is the final velocity. Very important formula. So acceleration is equal to initial minus final velocity by time. Initial velocity. Here, how to write all those? Initial velocity minus final velocity. Okay, so that is a is equal to v minus, sorry, not initial, final velocity minus initial velocity by time. Okay, that means we have to take reverse. Final velocity, change in velocity means final to initial one, na? Initial by time, v minus u by time. Okay, r a is equal to, if you have only one velocity, let's take that is a v, dv by dt. Then what will be the unit? Velocity meter per second by time second, that is meter per second square. Very important. Acceleration units meter per second square. Acceleration units meter per second. Okay, clear? So in the same way, if you take the curve, if it is the velocity, if it is the time, as v increases, t also increases, then there is a slope is there. Slope change in y-axis by change in x-axis, r dv by dt. That is nothing but acceleration. So you can note down here, slope of velocity time graph gives acceleration. Okay, so whenever the velocity is increases, then only you can say that is the acceleration. If the velocity is decreases with respect to time, then that is a deceleration. So note down that point. Okay, if velocity increases with the time, then you can say that is called as acceleration. In the same way, if velocity decreases with respect to time, you can say that is a deceleration or retardation. Okay, deceleration or retardation. Okay, that means negative acceleration is called as retardation. Okay, negative acceleration. Negative acceleration called acceleration. Okay, and we have so many important points belongs to acceleration. Don't worry, we will discuss each and everything in the equations of motion. Okay, one more important thing, jerk. Okay, so here rate of change in velocity, acceleration. If any change in acceleration, that is the jerk. Rate of change in acceleration is nothing but jerk. So jerk J is equal to change in acceleration with respect to time. So units are acceleration meter per second square times second. So meter per second cube. Very important. Jerk units meter per second cube. Okay, jerk is nothing but rate of change in acceleration. Rate of change in acceleration. Okay. So students, in the next session, we will discuss about very important thing in the motion. So three important equations of motion. Okay. And with respect to gravity, all those three equations and maximum height. Okay. Time of ascent, time of descent, that is total time. And after that, projectile motion. Okay. So we will discuss all those in the next session. Okay, so don't forget to attend the next session also. And also please share the information to all your friends and please share and try to join the Telegram link I have given in the description box. Okay. And nothing. Okay. Okay, thank you guys.